How does depleting ozone affect global warming? By Aaron Williams. First, we'll look at temperature. The more ozone is given in a molecule of air, the more heat it retains. Ozone generates heat in the stratosphere, both by absorbing the sun's ultraviolet radiation and by absorbing upwelling infrared radiation from the lower atmosphere, the troposphere. Ozone depletion and climate change are linked in a number of ways, but ozone depletion is not a major cause of climate change. Atmospheric ozone has two effects on the temperature balance of the Earth. It absorbs solar UV radiation, which heats the stratosphere. It also absorbs infrared radiation emitted by the Earth's surface, trapping heat in the troposphere. CO2. The increase in carbon dioxide is the major contributor to climate change. Carbon dioxide concentrations are increasing in the atmosphere primarily from the burning of coal, oil, and natural gas for energy and transportation. Air pollution from coal. Fired power plants including sulfur dioxide, nitrogen oxides, particulate matter, and heavy metals, leading to smog, acid rain, toxins in the environment, and a number of respiratory and cardiovascular effects. Air pollution from coal mines is mainly due to emissions of particulate matter and gases including methane, sulfur dioxide, and nitrogen oxides, as well as carbon monoxide. Climate impacts on coal plants. Coal-fired power plants are responsible for 1/3 of America's carbon dioxide emissions, making coal a huge contributor to global warming. Oil. The smoke produced from oil fires will enter the ozone layer. This can cause breathing to become difficult and even cause death. The decrease of the quality of air has a direct impact on creating and enhance existing respiratory problems. Burning oil creates sulfur dioxide and nitrogen oxides in the air. When they combine with moisture, acid rain is created. Natural gases. Some areas where drilling occur have experienced increases in concentrations of hazardous air pollutants and 2 of the 6 criteria pollutants, particulate matter and ozone plus its precursors, regulated by the EPA because of their harmful effects on health and the environment. Sources of the methane include natural sources like wetlands, gas hydrates in the ocean floor, permafrost, termites, ocean freshwater bodies, and non-wetland soils. Fossil fuels are cattle, landfills, and rice paddies are the main human-related sources. Global warming. Many of the same gases that are causing ozone depletion are also contributing to climate change. These gases, such as the chlorofluorocarbons, CFCs, are greenhouse gases, absorbing some of the infrared radiation emitted by the Earth's surface, thereby heating the Earth's surface. The ozone layer absorbs most of the sun's harmful ultraviolet rays. Over the last half-century, widespread use of man-made compounds, especially household and commercial aerosols containing CFCs, have significantly and rapidly broken down the ozone layer to a point where the hole in the Antarctic ozone layer was discovered in the mid-1980s. Extra UVB radiation reaching Earth also inhibits the reproductive cycle of phytoplankton, organisms such as algae that make up the bottom tier of the food chain. Biologists fear that reductions in phytoplankton populations will in turn lower the populations of other animals. Moving on to atmosphere composition. Changes in the climate of Earth could affect the behavior of the ozone layer because ozone is influenced by changes in the meteorological conditions and by changes in the atmospheric composition that could result from climate change. The major issue is that a stratosphere will most probably cool in response to climate change. Ozone is found in 2 different parts of our atmosphere. Ground level, or bad ozone, is a human health irritant and component of smog. It is found in the troposphere and has nothing to do with the ozone hole. Good ozone occurs in the stratosphere and accounts for the vast majority of atmospheric ozone. The stratospheric ozone layer absorbs UV radiation, preventing dangerous UV rays from hitting Earth's surface and harming living organisms. The hole. Stratospheric ozone is produced by the action of the sun's ultraviolet radiation on oxygen molecules. Although oxygen is created primarily at tropical latitudes, large-scale air circulation patterns in the lower stratosphere move ozone towards the poles, where its concentration builds up. During this continuously dark polar winter, the air inside the polar vortices become extremely cold, a necessary condition for polar stratospheric cloud formation. Polar stratospheric clouds create the conditions for drastic ozone destruction, providing a surface for chlorine to change into ozone-destroying form. They generally last until the sun comes up in the spring. And lastly, we have our conclusion, the verdict. It's not the cause. The depleting ozone does not cause global warming. However, both of these environmental problems have a common cause: human activities that release pollutants into the atmosphere, altering it. The ozone hole is an area in the stratosphere above Antarctica where chlorine and bromine gases from human-produced CFCs have destroyed ozone molecules. Global warming is the rise in average global surface temperature caused primarily by the buildup of human-produced greenhouse gases, mostly carbon dioxide and methane, which trap heat in the lower levels of the atmosphere. There is a case where the depletion of the ozone layer from 8 to 25 miles up causes severe cooling in the lower stratosphere, which expands the troposphere and alters patterns of air circulation. This leads to a poleward shift of the band of the westerly wind circling the Earth in mid-latitudes. The study found these high-altitude shifts fed changes in the lower atmosphere that led to higher levels of precipitation in the subtropics.